All right, folks. So this is a problem that I went through in class. So we will do our best to get through it as painlessly as possible. It says you're lost in the woods. When you left camp, you walked 2 miles due north. Your desired destination was 3.5 miles from camp in the direction 25 degrees north of east. How far and in what direction do you need to walk to arrive at your final destination? All right. So the goal here is to figure out, you're lost in the woods, which way do I need to walk? So that's your goal. And as we do with many problems, the first step here is to kind of try to draw a picture, draw a sketch of what's going on. So we're going to say that you left camp and then you walked, 2 miles north. There we go. We're going to call that vector A. So we'll call this vector A, that 2 miles due north. It said your desired destination was 3.5 miles from camp. Let's see, at an angle of 25 degrees north of east. So let's see, if I think about the east direction, it's like out this way. If I'm going 25 degrees north of east, maybe it's something like this. So this point right there is really where we wanted to get to. For whatever reason, we just started out due north. So now the question is, well, what do I need to do? I'm there at the end of A. What do I need to do? What do I need to do to get to where I'm supposed to go? Well, I think I need to go from A to that asterisk right there. All right. I don't know what just happened with the graphic. So let's try and erase that real quick. And let's maybe do something else here. My apologies. There we go. So we made the vector black this time. There we go. All right. So if we take a look, we notice that red vector A and the black vector get us to our destination. So it's like we're taking A and B, and together they get us to where we would actually like to go, which we could have gone directly if we had just gone through path C. So what we have there actually is that A plus B is equal to C. All right. Now, I can't just add numbers directly. I've got vectors there, and vectors indicate that direction is important. I couldn't just say, well, I wanted to walk 3.5 miles. I walked 2 miles already, so I just need to maybe walk 1.5 miles, and that's done. Well, no, that's not going to get me to the right place. But what I can do instead is I can add up maybe the X part of A and the X part of B, and that would give me the X part of C. And I can do the same thing with the Y direction. Of course, if I look at the things that I'm actually trying to solve for in this problem, I'm trying to figure out, well, which direction do I need to walk in and how far do I need to walk? So I'm really asking about, well, what is this B sub X? What is this B sub Y? And if I figure those things out, then maybe I can figure out how far I need to walk and in what direction. All right. So that is my goal. Let's see if I can remember now how to, let's see, advance. Yes. Okay, there we go. All right. So let us see here. So what I need to do at this point is to figure out, let's see, I got vector A right there. Let's figure out the X and Y components of vector A. Well, if we go back up to the original information, we'll see that vector A is 2 miles due north. Well, if it's 2 miles due north, then there is no X direction for A. A sub X, the X component of A, is just 0. Well, the Y component of A is 2 miles. That's great. All right. So done with that. Let's see, what other information do we have? We know something about vector C. It said vector C, and I'm a little bit off there on my angle, but this is going to be good enough. Vector C is right there, and it is at 25 degrees north of east. I'll draw that number in just a second. What we can do with vector C is we can break it down into its X and Y components. how do I do that? Well, I start where vector C starts, and then I just start kind of drawing a dashed line in the x direction until I get to a spot that's right below where my end arrowhead is for C, so that when I draw my next leg, I can just draw it straight up. So that leg in the right there in the x direction is C sub x. That's my x component for vector C. Well, now I draw a leg straight up. There we go. At least it's supposed to be straight up, and that's C sub y right there. All right. We were told that vector C has a length of 3.5 miles. And we were told that vector C is at an angle of 25 degrees. Whoops, there's that funny thing again. I don't know why it's doing that. There we go. Probably has something to do with the fact that I'm using my finger as a stylus. That's I don't know. You could either look at this as, you know, the cheapest stylus possible, or possibly the most expensive one, because it's attached to the rest of my body, and I think I'm a pretty valuable thing. Right. Okay. At any rate, we've got our vector there, or we've got our triangle there. We can see that the hypotenuse, that vector C, has a length of 3.5 miles. We can see that we've got the angle of 25 degrees. And now we can proceed to figure out what C sub x and C sub y are. This should be adjacent for C sub x and opposite for C sub y. All right. We know SOHCAHTOA, cosine of 25 degrees, is going to be equal to adjacent over hypotenuse. My adjacent side is the C sub x side. My hypotenuse is 3.5 miles. There we go. So if I multiply this out and solve for C sub x, I get C sub x is equal to 3.5 miles times the cosine of 25 degrees. And if I plug that into a calculator, I will get out the result 3.17 miles. Okay. What about C sub y? Well, if we used cosine to figure out C sub x, we can do the exact same set of operations and use, why is it doing that? I don't know, but it's annoying. We can go through the exact same set of operations and use sine to figure out C sub y, because now we're figuring out the opposite side. And when we do this, we are going to get out the result that C sub y is 1.48 miles. All right, those are important. There we go, that one, and these two right there. All right. Let's go to maybe some more space here. We're going to keep that stuff in mind. Let's go to some more space, and let's proceed with the problem. All right, well, we know that if we add A and B together, we get C. Whoops, not that way we don't though. If we add A and B together, we get C. So it's important when we do this, though, that we add the x components to the x components and the y components to the y components. My unknown here is B sub x. That's the thing I don't know. So there we go. We got C sub x minus A sub x is going to give us B sub x. All right, let's plug in numbers. 3.17 miles minus 0 miles gives me 3.17 miles. All right, we do the exact same thing for the y components. And what do we get out? We get out 1.48 miles minus 2 miles gives me a negative 0.52, and I ran out of space, miles. Okay. All right, so now what? Well, we figured out the x and y components of B, but what we would actually like to know is well, you know, I'm lost in the woods. How far do I actually need to walk? Because I'm not going to walk along the X direction and then walk along the Y direction if I don't have to. I'm going to take a straight line, right? So let's see, I'm here. Whoops, I'm there. I need to go in the X direction, and then I need to go in the Y direction. Okay. This is B sub X. This is B sub Y. And then if I complete that right triangle there, that will give me B. And that B is what I would like to know. I'd like to know how far I have to walk. All right, well, we can see that we've got a right triangle there. If we've got a right triangle, we can use the Pythagorean theorem. And I'm skipping a step or so here, but we know that the square of the two shorter sides summed together is equal to the square of the hypotenuse. That's another way to say, to give the Pythagorean theorem. If we now stick in numbers here for our B sub X and our B sub Y and complete the math, we will get out the result that vector B has a length of 3.21 miles. Okay, at first it was kind of funny that thing kept happening. Now it's just annoying. 3.21 miles. There we go. So that's important. 3.21 miles. That's great, but at what angle? Well, let's see. There's my angle theta. So it looks like I'm measuring my angle theta off of the east direction. So let's see, if I were lost in the woods, I would point my body east, and then I would turn to the right a little bit in order to be able to go the direction that I need to go. So how far do I need to turn? Well, tangent of theta is equal to opposite over adjacent. Whoops, what happened? That's no good. Opposite over adjacent. Okay, that is equal to B sub Y over B sub X. What is B sub Y? B sub Y is 0.52 miles. I just use the positive value there because it's a triangle, and triangles have positive side lengths. Not only that, but if I stick in a negative number with the trig function, sometimes I'll get a negative angle back, and then maybe that's a little confusing and we don't know what to do with that. So whenever I'm dealing with triangles and I've got a sketch, I just use positive side lengths. All right. So when we figure out what theta is, we get that theta is equal to, we figure out theta by taking the inverse tangent of both sides. We get theta is equal to 9.31 degrees. And then what's the direction? The direction is, well, let's see, I'm pointed east, but I got to go a little bit south of east. So it's 9.31 degrees south of east. So there's our direction. And there's the answer for the problem. 3.21 miles and 9.31 degrees south of east is how far we have to walk. All right.